Corporate Finance Practice Problem using OneNote. Expected Value Standard Deviation and Coefficient of Variation Problem number 3. Get ready, it's time to take your chance with Corporate Finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side in the Practice Problems tab, then down in the 1314 Expected Value Standard Deviation and Coefficient of Variation Problem number 3. Also note, when using OneNote, take a look at the immersive reader. Many of our presentations up top will be down here in the text area as well. Same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, information is going to be up top. We're going to go through the calculations then on down below. This is our third practice problem with a similar scenario, so we'll go a bit faster at it. We want to get an idea, a feel for the layout so we can set these things up fairly quickly. We're going to be projecting into the future. This is going to be a way for us to try to use some statistical kind of analysis in order to make the projections into the future. We can apply these to different things, different characteristics, which we will do in future presentations, and we want to get the format down to do so. So we have our possibilities down below. We're imagining the advertising campaign. We got the categories of bad, good, and very good. Note that the categories are not as important as, of course, the numbers within the categories, but they can give you an idea of what we're talking about in terms of the category names. We then want to measure what it means to be in these categories with whatever we're going to measure by, in this case being the unit sales. So with advertising campaigns, this would often be useful or necessary so that we can continue on with our budgeting plan, because we need to know how many we're going to sell in order to know how many we need to buy to have our inventory. And if we make the inventory, then we would need to know how much we need to make for a certain time period. And this would be the kind of the starting point for our budgeting type of information. So important number then. So note you could have more than 3 categories here. We could have anywhere from like 1 to 5 is kind of typical, and then come up with our statistical kind of thought process. And we then would need to assign the probabilities to those categories. The probabilities then must add up to 100. So in this case, we're going to say bad is the 600, good is going to be the 800, very good, the 1,400. Where would we get that information? Possibly from prior advertising campaigns and or then projecting out into the future, starting off with past data if we have it, and then project out into the future, just giving our best guess and categorizing where we would be under different scenarios. Then we want to weight the likelihood for those scenarios. So if it was bad, we're going to say the 30% good or average possibly. That would be the 50%. You would kind of expect that one to be the larger of the percentages, right? And then very good at the 20%. The percentages needing to add up to 100%. Expected value then being the 600 times the 30%, or the 180, the 800 times the 50%, or the 400, the 1,400 times the 20%, or the 280. Adding up the 180, the 400, and the 210, we get up to the 860. Note that 860 is basically kind of like the average or the mean, as we'll basically go to and try to get a better handle of by taking this data and putting it into a normal kind of data set down below, a list of numbers that we can do our statistic kind of calculations on. And it'll be more similar to the calculations you might see in a statistics course, where you might start off with a list of numbers that you want to apply some statistical analysis to. So let's reset these numbers into basically a list of 10 numbers just to get a feel for that, and then we'll go down after that and do the kind of more normal type of calculation that we might see in this setting, corporate finance type of setting. So let's take these numbers. If we say, okay, if there's a 30 weighting, a 50% weighting, and a 20% rating, and I had 10 numbers, then it would look something like this. The 600 we're going to imagine is 3 out of the 10, right? 3 out of the 10 is going to be the 600. Then we're going to imagine the 4 out of the 10, or the 5 out of the 10 here, because that's 50%. So 5 out of 10, and then the last would be the 1,400, would happen 2 times out of 10. Adding up, these are 10 items then that we're talking about here. Then we can calculate the mean on this. Now, what we're going to be looking into is basically this formula, which is the population variance. So we're going to be taking each of the items compared to the mean, or the average, squared divided by the population, which are 10 numbers that we just put together at this point. So the mean or the average, if we were to take these 10 numbers and do our calculation on that, let's do that. 600 plus 600 plus 600 plus 800 plus 800 plus 800 plus 800 plus 800 plus 1400 plus 1400 equals the 8600. We're going to divide by the population, which is 10 of them. There's 10 of these numbers here. Divided by 10. That's going to give us our average or mean of 860. Remember, that's kind of like the center point, not the median, not like the middle number, but the average, right? That's going to be the average that we're looking for. So we're going to take that all the way down as the 860 for the mean or the average. Then we're going to take the difference, subtracting this out. We're basically up here now, the difference for each of the numbers to the mean. If we take the 600 minus the 860, we get a negative 260. Bringing this all the way down to the 800 minus the 860, we get 60. And then we take this all the way down to the last couple where we have the 1,400 minus the 860 is the 560. Then we apply our squaring. So that's going to be here in our calculation. We're going to do our squaring thing now. That's what we're in, the square thing. And so we're going to then take the calculator up. We'll take the 260 squared. And that's going to be the 67.6. 67.6. So we're going to say there it is, 67.6. Squaring these. That, of course, removes the negative here. So I didn't put a negative in the calculator, but the negative goes away when you square it. That's part of the reasoning, the rationale. The rationale. So the negative 60 squared is the 3006, negative 60 squared, and so on. And then the 540 squared, 291,600. Then if we add these up, then we add all these up, there's our 804,000. Now that's our numerator basically up top. Then we're going to divide it by the population, which we saw was 10, because there's 10 items, there's 10 number of things. That's the population size. So if we take the 804,000 divided by 10, we're at the variance of the 80,400. Remember that that's kind of like squared units. So typically we'll take the standard deviation, which is the square root of that. So square rooting it, meaning we're gonna pull in that number, the 80400, and then square root is going to be the 283.55. So there we have that. And then we might want the mean here, the 860, to get to the bottom line of the coefficient of variation, which you might see presented as a percent or a decimal of 0.3297. This number becoming important to us when we do comparisons of multiple projects, such as multiple advertising projects, which we don't have yet, but we'll do shortly. Note that you can also see these calculations just in Excel, so you can have functions for these calculations. So you might just see it like this, where it would be the mean or the average. The mu would be the average formula equals average of the series of numbers, which would be just this 10 numbers. The series of numbers would give you that 860 once again. You can have the standard deviation, which would be the STDEV.P. The .P stands for population versus sample. We're using population here. If you want to know the difference between the population and the sample, there's many statistical kind of things on YouTube and the internet. You can look at that. Great material for it. Worth too. Then we got the variance, and that's going to be, you can calculate that with a formula, which would be equals VAR.P. Once again, the P stands for the population versus the sample. So we're talking about a whole population versus a sample population, and that would be the same series of numbers, and that would give you the 80,400, matching the 80,400 up top. And then we can calculate the coefficient of variation same way we did up top, just taking the standard deviation divided by the mean, standard deviation over divided by the mean. So then let's do the same kind of thing with the standard corporate finance kind of layout, where we're going to do the probabilities at the end. So we'll just twist around the calculations a little bit. So this time, same kind of thing, getting to the same result, but different method, shorter method. This time, the standard type of method. So we're now going to have the 600, the 800, the 1,400, same unit sales we're expecting for our three categorizations here. The expected value then, which we now see is kind of like the average, the mean, the expected value. It's a well-known figure. It goes by many names, 860. And then the difference is going to be the 600 minus the 860 is the negative 260, 80 minus the 860, negative 60, and then the 1,004 minus the 860 is the 540. Then we will square it. So we're going to take the 260 squared, or the negative 260 squared gives us the 67.6. The 60 squared gives us the 3,600, and the 540 squared gives us that 291,600. Then we're going to apply our probabilities at the end here. Then we're going to apply the probabilities at the end, which is going to be the 30, 50, 20. 30, 50, 20, 67.6 times 30%, 20,280. The 3,600 times the 50%, 1,800. The 291,600 times 20% is the 58,320. So then we have our variance, which will be calculated as the 20,280 plus, these three numbers. I won't say the numbers. Those three numbers add up to 80,400. Same variance we got to up top. So now we're basically back to the same point we did up top with this different kind of format of the calculation. Standard deviation, then square root of the 80,400. The 283.55, same calculation we had up top. Then we're going to take that, divide it by the mean, or the average, which we're now calling the expected value we got here and we got up top here. And that's going to give us then the coefficient of variation. Now remember, depending on the problem you are using, you might end up having a problem that just stops here. You need the expected value. That's what you need for something like inventory, so you can do your budgeting going forward, possibly. But if you're kind of comparing then, one option to another, which we'll talk about in future presentations, then this is typically the number that will be helpful for that, because that's going to help you to compare different numbers that possibly have different kind of dollar amount or unit amounts with them, and you can kind of measure the spread away from, the mean with the coefficient of variation.